When brushing or selecting items in a visualization, analysts often select patterns that seem interesting. For example, a user may be looking for outliers or clusters. The goal of this project is to infer the intent behind these selections. Why do we care about predicting intents? First, we can use predicted intents to autocomplete selections. In this example, we select only one outlier and then use a prediction to autocomplete our selection. Second, capturing intents enables reproducibility and reusability. Typically, selections are stored using lists of identifiers. If we instead store the semantics behind a selection, like a cluster centered at 2, 3, we capture a higher level concept. Having this information improves reproducibility, as it is obvious after the fact what the intention was. Storing higher level concept also makes selections robust to changes in the dataset. If a new point were added, for example, it could be automatically included in a selection. To identify common patterns, we ran a formative study in which we interviewed domain experts that often work with scatterplots. We found that these experts were interested in outliers, clusters, correlations, categories, multivariate optimization, and ranges. So how do we infer intent? First, a user selects items in a dataset. We then calculate a large number of patterns using a variety of algorithms, such as k-means, db-scan, outlier detection, and so on. We compare each prediction to the selection using different similarity metrics and rank them. Finally, an analyst can select a prediction that matches their actual intent and add annotations. Now let's take a look at the system in action. The system is composed of 4 views: the scatterplots, a predictions view, a selections view, and a history view. We can interact with the plot by selecting items using a rectangle brush or a paintbrush. The system then calculates a list of predictions. A pop-up menu enables us to autocomplete a selection. Here we select a few points outside the linear regression trend, and we can rapidly select all other similar points predicted by our tool. Predictions are ranked using different metrics. 2 metrics are optimized to predict the intent of a complete selection. Another one is optimized for autocompleting a partial selection. For each prediction, we show how well it matches the selection. The dimensions column tells us on which dimension the prediction was calculated. The match column represents items that are both in the user selection and the prediction. The not predicted column displays the items that we selected but that are not predicted by the algorithm. The not selected column shows the items predicted by the algorithm but not selected by the user. We can hover on a prediction to highlight the points that are part of that prediction. Clicking a prediction applies the prediction and replaces any previous selection. Every action we take is logged in the history graph on the right. We can save an insight and add an annotation to it. Insights are useful to group previous actions. We can aggregate all actions that lead to an insight, which makes the provenance graph easier to manage. Let's walk through an example based on the Gapminder dataset, which contains metrics about various countries' economy and public health. We start with a plot of GDP versus child mortality rates. We want to find the continent with countries that have small economies and poor overall health conditions. To do this, we add a second plot of GDP versus life expectancy, which is a good metric for the quality of health conditions. We start by using a brush to select countries with low GDP and high child mortality rates. Notice that this highlights these countries in both plots. We add a second brush to select all countries with low GDP and low life expectancy as well. Looking over at the predictions panel, we see that the top prediction is a category. Because we are interested in finding the continent with countries that fit our criteria, we hover on the category prediction to inspect that selection. There are 54 countries that match this prediction, only 10 of which are not part of our selection. These 10 countries also have low GDP, but high life expectancy and low child mortality rates. We can then click on the category prediction to turn it into a selection. We save it as an insight and add an annotation. A lot of countries with smaller economies and poor medical conditions are part of the African continent, but not all countries in Africa fit our pattern. We evaluate our method in interviews with domain experts and in a quantitative crowdsourced study with 128 participants. We compared user-driven mode, where only brushes were available, with computer-supported mode that included the prediction interface. We found that participants were more accurate for difficult tasks for all patterns except for outliers. Please look at the paper for details. Thank you for watching our video.